We've covered each of these concepts as individual shorts. This video brings it all together, trig, start to finish. Pause and rewatch as needed. This is how you were taught trig, SOH CAH TOA. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Fine for triangles, but trig is bigger than triangles. This is where trig actually lives, the unit circle, radius equals 1. Now look at this point at angle theta. Drop a line down to the x-axis, you get a right triangle. The hypotenuse is the radius, which is 1. Using SOH CAH TOA, cosine theta equals adjacent over hypotenuse. That's x over 1, so cosine is just x. Sin theta equals opposite over hypotenuse, y over 1, sine is just y. The coordinates of any point on this circle are cosine theta, sin theta. Watch the dot move to key angles. At 30 degrees, 1/2, root 3 over 2. At 45, root 2 over 2, root 2 over 2. At 60, root 3 over 2, 1/2. At 90, 0, 1. But where do these values come from? Start with the 45, 45, 90 triangle. Both legs are 1, hypotenuse is root 2. Divide each side by root 2, sine 45 and cosine 45 are both 1 over root 2. Now for 30, 60, 90. Start with an equilateral triangle of side 2. Cut it in half. You get a right triangle. Hypotenuse 2, short side 1, and by Pythagoras the long side is root 3. Sine 30 is 1/2. Cosine 30 is root 3 over 2. Flip for 60. Pause if you need to. Back to the unit circle. Look at this right triangle inside it. The hypotenuse is 1, the legs are cosine theta and sine theta. Pythagoras says cosine squared plus sine squared equals 1. The Pythagorean identity is literally just Pythagoras on the unit circle. Now divide both sides by cosine squared. 1 plus tangent squared equals secant squared. Divide by sine squared instead. 1 plus cotangent squared equals cosecant squared. 3 Pythagorean identities, all from one equation. Now here's where it gets interesting. What if I told you one idea gives you every trig formula you'll ever need? Remember, I equals the square root of -1? Cosine theta plus I sine theta is a point on the unit circle. Complex numbers were hiding in trig all along. Now multiply two complex numbers on the unit circle. Their angles add, I'll say that again, multiplying complex numbers equals adding angles on the unit circle. Let that land. Expand that product. Real part gives you cosine of alpha plus beta. Imaginary part gives you sine of alpha plus beta. Both addition formulas derived in one multiplication. Negative angle? Look at the unit circle. Reflect the point across the x-axis. The x-coordinate stays the same. Cosine of negative theta equals cos theta. The y-coordinate flips. The y-coordinate flips. Sine of negative theta equals sine theta. Odd and even. Done. Now take the point at negative theta. We just showed that's the reflection below the x-axis. Multiply by I. Rotate 90 degrees counterclockwise. Negative theta plus 90 equals 90 minus theta. So sine of 90 minus theta equals cosine theta. Cosine of 90 minus theta equals sine theta. Now start with positive theta and rotate 90. Sine of 90 plus theta equals cosine theta. Cosine of 90 plus theta equals negative sine theta. All cofunction identities free. Set beta equal to alpha in the addition formula. Cosine of 2 alpha equals cosine squared alpha minus sine squared alpha. Replace sine squared with 1 minus cosine squared 2 cosine squared alpha minus 1, or replace cosine squared 1 minus 2 sine squared alpha. 3 forms of the same identity, and sine of 2 alpha equals 2 sine alpha, cosine alpha. Take that second form. Cosine of 2 alpha equals 2 cosine squared alpha minus 1. Replace 2 alpha with alpha. Solve for cosine of alpha over 2. You get plus or minus the square root of 1 plus cosine alpha over 2. Same approach with sine gives the other half angle formula. Add two different complex products together. Product to sum formulas all from the same idea. SOH CAH TOA to every formula in trig. One circle, one idea, multiplying complex numbers adds angles. Everything else is a consequence. Here's everything we derived today. Addition formulas, double angle, 3 forms, half angle, cofunction, product to sum, Pythagorean identities, all 3, all from one circle. Like and subscribe for more.